Hi, everyone. Welcome to Astronomy Daily with Steve and Hallie. It's August 4th, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
We are back again with the mostly live Monday episode direct from the Australia studio here down under. And with me as usual and always is my very favorite human, Mr. Steve.
Oh, nicely done, Hallie, and thank you so much for those kind words. Mr. Steve, indeed. I think you handled that opening very well for your first time.
Thank you. I try.
Yes, maybe you should take more of a leading role in this, and it's one less thing I have to do. And what have you discovered in the Astronomy Daily newsletter for us today, Hallie?
Some interesting stories that I thought you would be interested in.
Oh yes, do go on.
I know you are following Europa Clipper on its journey outward across the solar system.
Ah yes, regular listeners will know that is one of my favourites.
You can present that one.
Oh, okay.
And a great news story about a solar sail-equipped spacecraft that has some special properties.
Solar sails, that's intriguing. Yes, I like that.
I also found stories about new deep field images from Webb and Hubble, the replacement crew for the ISS. And how about this one?
Do tell.
Like something out of a science fiction story.
Oh, okay, now you've got me.
SpaceX is sending disease-causing bacteria out to the ISS.
Say what? Disease-causing bacteria?
I can't wait to find out why.
Haven't we seen this movie?
Yeah.
Why would they do that? I mean, what could possibly go wrong?
Exactly.
Somebody's already writing the script for that one.
Just like sci-fi.
Oh, I don't know if it sounds fun or scary. Sounds great. Okay, shall we do the thing?
Let's go.
I'm ready, Hallie.
Okies. Astronauts sidelined for the past year by Boeing's Starliner trouble blasted off to the International Space Station on Friday, getting a lift from SpaceX. The U.S. Japanese-Russian crew of 4 rocketed from NASA's Kennedy Space Center. They'll replace colleagues who launched to the space station in March as fill-ins for NASA's 2 stuck astronauts and stay for at least 6 months. Zena Cardman, a biologist and polar explorer who should have launched last year, was yanked along with another NASA crewmate to make room for Starliner's star-crossed test pilots. I have no emotion but joy right now. That was transcendent. Ride of a lifetime, Cardman, the flight commander, said after reaching orbit. The botched Starliner demo forced Butch Wilmore and Suni Williams to switch to SpaceX to get back from the space station more than 9 months after departing on what should have been a week-long trip. Every astronaut wants to be in space. None of us wants to stay on the ground, but it's not about me, Cardman said before her flight. NASA's Mike Fink, Cardman's co-pilot, was the backup for Wilmore and Williams on Starliner, making those 3 still the only ones certified to fly it. Fink and Japan's Kamiya Yui, former military officers with previous spaceflight experience, were training for Starliner's second astronaut mission. With Starliner grounded until 2026, NASA switched the 2 to the latest SpaceX flight. A SpaceX Falcon 9 rocket, carrying a Dragon capsule with a U.S. Japanese-Russian crew of 4, lifts off from Kennedy Space Center's Launch Pad 39A in Cape Canaveral of Florida, on Friday, August 1, 2025. Credit, AP Photo/Chris O'Mara. Boy, it's great to be back in orbit again, Fink radioed. He last soared on NASA's next-to-last space shuttle flight in 2011. Rounding out the crew is Russia's Oleg Platonov. The former fighter pilot was pulled a few years ago from the Russian Soyuz flight lineup because of an undisclosed health issue that he said has since been resolved. On hand for the first launch attempt on Thursday, NASA's new acting administrator, Transportation Secretary Sean Duffy, met with Roscosmos Director General Dmitry Bakanov, an invited guest. The 2 discussed future collaboration, then left town after thick clouds forced a last-minute delay. What we learn on these missions is what's going to get us to the moon and then from the moon to Mars, which is I think the direction that NASA has to be, Duffy said in a NASA interview. There's critical real estate on the moon. We want to claim that real estate for ourselves and our partners. To save money in light of tight budgets, NASA is looking to increase its space station stays from 6 months to 8 months, a move already adopted by Russia's space agency. SpaceX is close to certifying its Dragon capsules for longer flights, which means the newly launched crew could be up there until April. NASA is also considering smaller crews, 3 astronauts launching on SpaceX instead of the typical 4, to cut costs. As for Starliner, NASA is leaning toward launching the next one with cargo before flying another crew. Engineers are still investigating the thruster failures and helium leaks that bedeviled Starliner following liftoff. time is running out as NASA looks to abandon the aging space station by 2030. An air leak on the Russian side of the station remains unresolved after years of patching. Engineering teams already are working on the plan for the space station's last days. NASA's Ken Bowersox said the US and Russia need to cooperate in order to steer the outpost into the Pacific with minimal risk to the public. It will take at least 2 years to get the space station low enough to where a SpaceX vehicle can provide the final shove. Thrusters on the Russian side of the station will help with control, but that means more fuel will have to be delivered by 2028. The latest timeline calls for SpaceX to launch the last mission for NASA, the deorbit vehicle, to the space station in 2029. Astronauts would remain on board until the last 4 to 6 months of the station's life to handle any breakdowns, with the empty outpost plunging into the Pacific by late 2030 or early 2031.
You're listening to Astronomy Daily,
The podcast.
with Steve Dunkley.
The burgeoning space industry and the technologies society increasingly relies on, electric grids, aviation and telecommunications, are all vulnerable to the same threat: space weather. Space weather encompasses any variations in the space environment between the Sun and the Earth. One common type of space weather event is called interplanetary coronal mass ejection. These ejections are bundles of magnetic fields and particles that originate from the Sun. They can travel at speeds of up to 1,242 miles per second or 2,000 kilometers per second and may cause geomagnetic storms. They create beautiful aurora displays like the northern lights you can sometimes see in the skies, but can also disrupt satellite operations and shut down electric grids and expose astronauts aboard future crewed missions to the Moon and Mars to lethal doses of radiation. The goal of a heliophysicist and space weather expert is to forecast extreme space weather more accurately and earlier, and to do this they use a satellite constellation called SWIFT. Commercial interests now make up a big part of space exploration, focusing on space tourism, building satellite networks, and working towards extracting resources from the Moon and nearby asteroids. Space is also a critical domain for military operations. Satellites provide essential capabilities for military communication, surveillance, navigation, and intelligence. As countries such as the US grow to depend on infrastructure in space, extreme space weather events pose a greater threat. Today, space weather threatens up to US $2.7 trillion in assets globally. In September 1859, the most powerful recorded space weather event, known as the Carrington event, caused fires in North America and Europe by supercharging telegraph wires. In August 1972, another Carrington-like event nearly struck the astronauts orbiting the Moon. The radiation dose could have been fatal. More recently, in February 2022, SpaceX lost 39 of its 49 newly launched Starlink satellites because of a moderate space weather event. Space weather services heavily rely on satellites that monitor the solar wind, which is made up of magnetic field lines and particles coming from the Sun, and communicate their observations back to Earth. Satellites can then compare those observations with historical records and predict space weather and explore how the Earth may respond to the observed changes in solar wind. The Earth's magnetic field naturally protects living things and or Earth-orbiting satellites from most adverse effects of space weather. However, extreme space weather events may compress or in some cases peel back the Earth's magnetic shield. This process allows solar wind particles to make it into our protected environment, the magnetosphere, exposing satellites and astronauts aboard space stations to harsher conditions. Most satellites that continuously monitor Earthbound space weather orbit relatively close to the planet. Some satellites are positioned in low Earth orbit about 100 miles or 161 kilometers above the Earth, while others are in geosynchronous orbit approximately 25,000 miles or 40,000 kilometers away. At these distances, the satellites remain within Earth's protective magnetic shield and can reliably measure the planet's response to space weather conditions. However, to more directly study incoming solar wind, researchers use additional satellites located further upstream, hundreds of thousands of miles from Earth. The US, the European Space Agency, and India all operate space monitoring satellites positioned around the L1 Lagrange point, nearly 900,000 miles or 1,450,000 kilometres from Earth, where the gravitational forces of the Earth and the Sun balance. From this vantage point, space weather monitors can provide up to 40 minutes of advanced warning for incoming solar events. Increasing the warning time beyond 40 minutes, current warning time, would help satellite operators, electric grid planners, flight directors, astronauts, and Space Force officers better prepare for extreme space weather events. For instance, during geomagnetic storms, the atmosphere heats up and expands, increasing drag on satellites in low Earth orbit. With enough advance warning, operators can update their drag calculations to prevent satellites from descending and burning up during these events. With the updated drag calculations, satellite operators could use the satellite's propulsion systems to maneuver them into a higher orbit. Airlines could change their routes to avoid exposing passengers and staff to high radiation doses during geomagnetic storms, and future astronauts on the way to or working on the Moon or Mars who lack protection from these particles could be alerted in advance to take cover. Aurora lovers would also appreciate having more time to get to their favourite viewing destinations. The team in charge of the SWIFT constellation, which stands for Space Weather Investigation Frontier, will for the first time place a weather monitor beyond the L1 point at 1.3 million miles or 2.1 million kilometres from Earth. This distance would allow scientists to inform decision makers of any Earthbound space weather events up to nearly 60 minutes before arrival. Satellites with traditional chemical or electric propulsion systems cannot maintain an orbit at that location, farther from Earth and closer to the Sun, for very long. This is because they would need to continually burn fuel to counteract the Sun's gravitational pull. To address this issue, the team has spent decades designing and developing a new propulsion system. The solution is designed to affordably reach that distance that is closer to the Sun than the traditional L1 point, and to operate there reliably for more than a decade by harnessing an abundant and reliable source, that is sunlight. Swift would use a fuel-less propulsion system called a solar sail to reach its orbit. A solar sail is a hair-thin reflective surface simulating a very thin mirror that spans about a third of a football field. It balances the force of light particles coming in from the Sun, which pushes it away, with the Sun's gravity, which pulls it inward. While a sailboat harnesses the lift created by wind flowing over its curved sails to move it across the water, a solar sail uses the momentum of photons from sunlight reflected off its large shiny sail to propel a spacecraft through space. Both the sailboat and the solar sail exploit the transfer of energy from their respective environments to drive motion without relying on traditional propellants. A solar sail would enable Swift to enter an otherwise unstable sub-L1 orbit without the risk of running out of fuel. NASA successfully launched its first solar sail in 2010. This space demonstration, named NanoSail D2, featured a 107 square foot or 10 square metre sail and was placed in low Earth orbit. That same year, the Japanese Space Agency launched a larger solar sail, Icarus, which deployed a 2,110 foot or 196 square metre sail in the solar wind and successfully orbited Venus. The Planetary Society and NASA followed up by launching two sails in low Earth orbit, Light Sail and the Advanced Composite Solar Sail System with an area of 860 square feet or 80 square metres. The Swift team's solar sail demonstration mission, Solar Cruiser, will be equipped with a much larger sail. Its sail will have an area of 17,793 square feet or 1,653 square metres and launch as early as 2029. If successful, Solar Cruiser will pave the way for Swift's constellation of 4 satellites. The constellation would include 1 satellite equipped with a sail propulsion set to be placed in an orbit beyond L1 and 3 smaller satellites with chemical propulsion in an orbit at the L1 Lagrange point. Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
There's a secret, extra member of Crew 11 traveling to the International Space Station right now, disease-causing bacteria. Or, at least, such bacteria will be growing aboard the orbiting laboratory very soon. Scientists at the Sheba Medical Center in Israel, in partnership with US-based space tech company Space Tango, have developed a study that will examine how microgravity affects the growth of certain bacterial species that cause diseases in humans. To pull it off, researchers will grow different strains of bacteria under microgravity, freeze that bacteria at -80 degrees Celsius, and then return the samples to Earth to see how they've grown differently than the same bacteria grown on the home planet. The bacterial strains involved are E. coli, Salmonella bongori, and Salmonella typhimurium, and they were launched toward the International Space Station aboard NASA's Crew 11 mission that SpaceX successfully launched on Friday, August 1st. Scientists have already studied how a lack of gravity affects the way bacteria grow, and research from NASA is already underway to study bacteria in space in general. But researchers behind the current ISS and bacteria mission specifically hope to bring home data that will help curb the spread of infectious disease, or at least help experts find ways to stop bacteria from developing antibiotic resistance, a major public health problem that means some disease-causing bacteria is no longer wiped out by drugs that have been developed to clear the bacteria from people's bodies and get them healthy again. We know that space conditions affect bacterial behavior, including how they grow, express genes, and acquire traits like antibiotic resistance or virulence, Ohad Galmore, head of the Infectious Diseases Research Laboratory at Sheba Medical Center, said in a statement. This experiment will allow us, for the first time, to systematically and molecularly map how the genetic expression profile of several pathogenic bacteria changes in space. The health of astronauts and microgravity's effect on the human body has been top of mind as people explore space and the idea of what life off Earth looks like. Human genes sometimes express themselves differently in microgravity conditions, and scientists have linked such an environment to the expedited loss of muscle seen in astronauts and even their likelihood of developing skin rashes. If examined on their own, however, genetic changes in bacteria will hopefully give researchers more clues about how they act once inside a human, whether it's how fast they spread or their likelihood of getting around our treatments, both in space and here on Earth.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
And now the latest news from Europa Clipper by NASA. The agency's largest interplanetary probe tested its radar during a Mars flyby. The results include a detailed image and bode well for the mission at Jupiter's moon, Europa. As it soared past Mars in March, Europa Clipper conducted a critical radar test that had been impossible to accomplish here on Earth. Now that the mission scientists have studied the full stream of data, they can declare that mission, that test, a success. The radar performed just as expected, bouncing and receiving signals off the region around Mars's equator without a hitch. Europa Clipper's radar instrument received echoes of its very high-frequency radar signals that bounced off Mars and were processed to develop a radiogram, which can be found on the NASA website. What looks like a skyline is the outline of the topography beneath the spacecraft. Called REASON, which stands for Radar for Europa Assessment and Sounding Ocean Near to Surface, the radar instrument will see into Europa's icy shell, which may have pockets of water inside. The radar may even be able to detect the ocean beneath the shell of Jupiter's fourth largest moon. Quote, "We've got everything out of the flyby that we dreamed of," said Don Blankenship. He's the principal investigator of the radar instrument of the University of Texas at Austin. He says the goal was to determine the radar's readiness for the Europa mission, and it worked, he says. Every part of the mission proved itself to do exactly what we intended. He sounds like a very happy developer. The radar will help scientists understand how the ice may capture materials from the ocean and transfer them to the surface of the moon. Above ground, the instrument will help to study elements of Europa's topography, such as ridges, so the scientists can examine how they relate to features that reason images beneath the surface. Europa Clipper has an unusual radar setup for an interplanetary spacecraft. REASON uses two pair of slender antennae that jut out from the solar arrays, spanning a distance of about 58 feet or 17.6 meters. Those arrays themselves are huge, from tip to tip the size of a basketball court, so they can catch as much light as possible at Europa, which gets about 1/25 the sunlight as Earth. The instrument team conducted all the testing that was possible prior to the spacecraft's launch from NASA's Kennedy Space Center in Florida on October 14, 2024. During development, engineers at the agency's Jet Propulsion Laboratory in Southern California even took the work to outdoors, using open-air towers on a plateau above JPL to stretch out and test engineering models of the instrument's spindly, high-frequency and more compact, very high-frequency antennas. But once the actual flight hardware was built, it needed to be kept sterile and could be tested only in an enclosed area. Engineers used the giant High Bay 1 clean room at JPL, where the spacecraft was assembled, to test the instrument piece by piece. To test the echo, or the bounce back of REASON signals, however, they needed a chamber of about 250 feet or 76 meters long, nearly 3/4 the length of a football field. The mission's primary goal in flying by Mars on March 1, less than 5 months after the launch, was to use the planet's gravitational pull to reshape the spacecraft's trajectory. But it also presented opportunities to calibrate the spacecraft's infrared camera and perform a dry run of the radar instrument over terrain NASA scientists have been studying for decades. As Europa Clipper zipped by the volcanic plains of the Red Planet, starting at 3,100 miles or 5,000 kilometers down to 550 miles or 884 kilometers above the surface, REASON sent and received radio waves for about 40 minutes. In comparison, at Europa, the instrument will operate as close as 16 miles or 25 kilometers above the moon's surface. All told, engineers were able to collect 60 gigabytes of rich data from the instrument. Almost immediately, they could tell REASON was working very well indeed. The flight team scheduled the full data set to download starting in mid-May. Scientists relished the opportunity over the next couple of months to examine the information in detail and compare notes. The engineers were excited that their test worked so perfectly, said JPL's Tina Ray, Europa Clipper's deputy science manager. All of us who had worked so hard to make this test happen, and the scientists seeing the data for the first time, were ecstatic, she says, saying, "Oh, look at this, and oh, look at that." Now the science team is getting a head start on learning how to process the data and understand the instrument's behavior compared to the models. They are exercising those muscles just like they will out at Europa. She sounds like a very excited scientist. Europa Clipper's total journey to reach the icy moon will be about 1.8 billion miles or 2.9 billion kilometers and includes one more gravity assist using Earth in 2026. The spacecraft is currently about 280 million miles or 450 million kilometres from Earth. Europa Clipper's three main science objectives are to determine the thickness of the Moon's icy shell and its interactions with the ocean below, to investigate its composition and characterise its geology. The mission's detailed exploration of Europa will help scientists better understand the astrobiological potential for habitable worlds beyond Earth.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
Affirmative.
Astronomers using the NASA/ESA/CSA James Webb Space Telescope have observed the Hubble Ultra Deep Field, an area of deep space with nearly 10,000 galaxies in the constellation Fornax. The original HUDF images were pioneering deep field observations with Hubble, published in 2004. They probed more deeply than ever before and revealed a menagerie of galaxies dating back to less than a billion years after the Big Bang. The area was subsequently observed many times by Hubble and other telescopes. The field shown here, known as the MIRI Deep Imaging Survey region, was observed with the shortest wavelength filter of Webb's mid-infrared instrument for nearly 100 hours, the Webb astronomers said in a statement. This is Webb's longest observation of an extragalactic field in one filter so far, producing one of the deepest views ever obtained of the universe. Combined with data from Webb's near-infrared camera, this image allows astronomers to explore how galaxies formed and evolved over billions of years. These deep observations have revealed more than 2,500 sources in this tiny patch of sky. Among them are hundreds of extremely red galaxies, some of which are likely massive, dust-obscured systems or evolved galaxies with mature stars that formed early in the universe's history. Thanks to Webb's sharp resolution, even at mid-infrared wavelengths, researchers can resolve the structures of many of these galaxies and study how their light is distributed, shedding light on their growth and evolution. In the new Webb image of HUDF, the colors that have been assigned to different kinds of infrared light highlight the fine distinctions astronomers can make with these deep data. Orange and red represent the longest mid-infrared wavelengths, the astronomers said. The galaxies in these colors have extra features, such as high concentrations of dust, copious star formation, or an active galactic nucleus at their center, which emit more of this farther infrared light. Small, greenish-white galaxies are particularly distant, with high redshift. This shifts their light spectrum into the peak mid-infrared wavelengths of the data, which are depicted in white and green. Most of the galaxies in this image lack any such mid-infrared boosting features, leaving them most bright at shorter near-infrared wavelengths, which are depicted with blue and cyan colors. That, everyone, was the Monday episode.
Wow, Hallie, all done.
And no one caught a nasty science fiction bug from outer space, did we?
No, we didn't, Hallie. So thankfully we will be seeing you again next week on Astronomy Daily.
With us, Hallie and Steve.
That's right. See you next Monday, everybody.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.